Welcome everybody, good morning. My name is Chad Hodges. I'm actually the VP of Business Development for Enterprise Networking Solutions here in Sacramento, California. We're an integrator here for the state and a lot of our public sector friends in the Northern California Bay Area. Today we are going to be having a conversation with our friends from Natural Resource Agency, Splunk, and Pure Storage. And the conversation is going to be around the proliferation of data and developing a data-driven enterprise. This is meant to be interactive, so if you have questions, we're not going to be doing any sort of presentations. It's going to be more of a dialogue about real-world scenarios, how things are being done, how they're being implemented, and what these three gentlemen are experiencing from their enterprise perspective and their customers' perspective. So without further ado, I'd like to have each of them introduce themselves. You probably noticed, if you know Tim Garza, he's not here today. In his studies, been kind enough to send Steve Croft from Natural Resource Agency. So Steve, you want to introduce yourself?
So I'm Steve Croft. I'm the Chief Innovation Officer for Water Resources and the Natural Resources Agency. My role is to help try to introduce technology into the to our constituents and our employees. Right now, the thing that we're mainly working on is delivering an analytics platform, a loop environment to our science and engineers around climate and water data.
Good morning, everyone. My name is Manish, Jiandani. I'm part of Splunk. I'm part of Solutions Marketing in Splunk, and I focus on the areas of business analytics and IoT. And my background has been in reporting, data warehousing, BI, and technologies like Hadoop.
How's everyone doing? My name is Chad Kenney. I'm the VP and Chief Technology Officer for Pure Storage for the Americas. So I'm overall the voice of the field from engineering. I've been focused on really defining the 3 to 5 year strategy for the enterprise and what products we should do to help solve some of those out there. And then also just understanding some of the challenges of customers and developing products that satisfy some of those.
So guys, we talk a lot about how technology is proliferating. We talked about, it was discussed this morning about how we've seen rapid growth of data and the organizations are creating data at a speed that we have not even been able to think about 10 years ago or even 5 years ago. So if I could, Steve, I want to start with you because we had a little conversation before we got started today about just some of the history within your own organization. 10 years ago when this event, for example, started, it started from a mainstay of the amount of data your agency was creating from a GIS perspective, but I know it's become so much more than that now. Could you speak a little bit about, take us on a little history lesson and maybe share with us where you are today and maybe where we can see you going in the near future?
Yeah, we collect a lot of data around, and my main experience is with water resources because that's where my main department is, and we collect a lot of water data. It's we have sensors and data loggers throughout the state. We also grab data from other data repositories, and one of the issues that we've had over the years is that a lot of this data tends to be siloed within the programs that they're using it. A program has a requirement, they go collect data around it, and then another program comes up and they collect data, and we've had an issue with all this data that is growing in our department being very hard to collaborate with and to correlate between. And so one of the things that we've been looking at the last couple of years is ways to kind of bring those together and do some tagging and cataloging, getting the data in a format to where it's discoverable and usable and be able to correlate between these data sets. And that's something that we're also extending out to the rest of the agency as well. They talked earlier about the growth of data, and we're really starting to see a tremendous upswing in the amount of data because we're starting to get into, we have a lot of data coming in from data loggers and sensors out in the field, and some of the other tenant members of our environment are going to be getting really into IoT, and getting into small nanosensors out in like fracking wells and bringing in power data from meters out in residential areas. So the amount of data that we have, it's actually getting too big for the traditional analytical methods that we've been using with relational databases and some of the desktop tools that we've had. And so that's really driving us into some of the more innovative technologies that we're looking at now.
Very exciting. Thank you very much. Manish, if you could, I think collecting all this data is great, but real-time analytics and what you can actually do once you have all that data, I think is important. Can you give some insight and some use cases as to, what you guys are seeing in the industry and where you maybe see, give us a little history give us a little view into the future of where it can go in terms of the analytics use?
Yeah, absolutely. So I think from a real-time perspective, traditionally, again, as Steve mentioned, there have been tools like the RDBMSs or other batch-oriented systems that have been useful for giving insights on a daily, weekly basis. But what we're seeing, again, especially with the advent of faster compute and cheaper storage, is that companies want to get towards more being real time, and it's been driven a lot by their customer experience journey. It's in today's environment, I think it's very easy in many industries for customers to switch companies and move to different vendors. So being able to gain that insight and be competitive and retain those customers, it's very important for them to gain real time insights. An example of a customer that is doing for that with Splunk is actually Gatwick Airport. They are the world's, I think that they're the world's largest airport in terms of flight capacity when it comes to a single runway. So they have a single runway that they manage. And for them, it's very important that they meet not only the mandates from the government, but also the SLAs that they've set up with the airlines. So what they are doing is actually they're taking data from not only their baggage handling systems, from their scanning systems, when passengers come in, from their queue systems, and they're trying to create a real-time insight into the aircraft turnaround process, because they want to make sure they can turn around these aircrafts pretty quickly to meet the government mandates and meet the SLAs. But then also they are using that same data to get real-time insights into the passenger journey through the airplane, through the airport actually. So they're doing analysis of the time it takes for them to kind of check in, to kind of go through the security boards and so on and so forth. So again, it becomes a customer experience perspective, because they can now track the journey from curb to gate, as they call it, and optimize processes where there are delays that cause impact on customer experiences. But then also this customer experience kind of turns around and becomes a revenue metric for them, because, for example, they can push 95% of their customers, of their passengers, through security in 5 minutes or less. That means that as a passenger, I'm spending less time in the queues, and I'm spending more time shopping in the retail segment as well. So it's beneficial for the airport, because they're competing for businesses with other airports in the neighborhood, like the Heathrow Airport. But then also it's good for the retailers, because now they have people coming in buying things rather than waiting to go through security. So real-time insights become very important in these kind of areas.
Wonderful. Thank you very much. Chad, we all know that our society has fast become one that has had a certain expectation with regards to performance, the speed by which we get access to things, the always-on mentality that we have, where all my data is always available. So we all know that the infrastructure of these things is that much more critical. Talk to us a little bit about what Pure Storage has been able to do, and maybe give us some use cases and some future insights if you could. I know you're actually going to be talking a little bit about this next week at your conference.
Yeah, so if you look at all of these applications, compute has been actually growing substantially. Networks have gotten faster and faster, but infrastructure was one of the bigger barriers to entry to actually getting real-time analytics done. And part of this was due to the fact that silos were built because the performance profile of that silo was built to that application. And consolidating all of it down enabled vast concurrency that infrastructure could never handle. And so you were never able to get real-time analytics if you were to put everything together. And then you couldn't correlate the data because the data wasn't all together in the first place. And so building platforms that enable folks to be able to get consistent latency results at high concurrency with large scalability was one of the unique things that we tried to attack in the market. This really wasn't something that was available, because you can hear it all, in some of the comments of cheaper storage tends to be attached to, overall analytics environments. But really it became the storage that was the, roadblock to get into this. And so what we did is we tried to figure out, hey, how do we fundamentally change the economics game so we can provide a cheap storage device that provides fundamentally higher value than what the traditional cheap storage device is out there? And then gave you scalability to be able to scale this almost infinitely. When you look at real-time analytics and Internet of Things, I would say Pure is one of the bigger Internet of Things companies from kind of the get-go. We created each one of our devices that send back telemetry data every 30 seconds. It sends back quite a bit of data to a point where, as a small company that's at 1,800 employees currently, we have about 6 petabytes of data that generates from our arrays just in about a 2-year time frame. All of that data has to have analytics run on it so that we can provide a very different customer experience to our customers to predict issues before they occur. Similar to what other customers are doing around analytics, we would never be able to do that unless we got consistent latency results with an all-flash type solution and deployed it on this. And really the vast difference between the two of it, if you look at databases or relational database models, latency was always a sensitive thing for them. If you look at Nielsen as an example, who does market analytics, they were running a report that typically would take them 6 to 8 hours to complete, and they would provide that report every 24 hours to their users. That same report running on just a flash-based architecture was taking about 19 minutes. And so they reduced the 6 to 8 hours down to 19 minutes. They could now monetize that report to give more real-time analytics to their users and then also sell them an hourly report, which now you could monetize a system which functionally paid for itself. So there's a lot of great use cases that enabled this with higher levels of concurrency and overall consistent latency results.
Appreciate that. Like I said before, this is meant to be interactive, so if there are questions that are spawned out of anything that we're discussing today, please don't hesitate to ask those questions. Our panelists are pretty open and candid and not shy. So, Steve, if you will, the different types of data, especially in government, that are being generated by all your agencies and even within Department of Water Resources, has to be vast. But how are you getting through the barriers of new types of data that might be coming to the table? And if you could maybe share what some of those are, and how are you finding you're able to respond to the proliferation of that, in addition to merging that with legacy data as well?
So we're going forward. We'll make sure that we're building up a Hadoop environment, as mentioned before. So we have a large data lake that will be our house for any types of new data coming forward. And so this is where we're bringing our legacy data, and then looking at some of our efforts with other agencies, bringing in other types of sensor data coming in, like I mentioned about power data. Those are kind of the things that we're looking at correlating across this data lake. One of the big challenges that we have, of course, is the governance around that. We're putting in a structure for tagging and building a catalog. This is something that we tried that we did with our GIS environment, so we have a little bit of expertise with that. But it was a challenge, and it will be a challenge in here because you're trying to get some commonality among all these disparate organizations. So that's probably our main effort at this point, is getting our data governance together to basically tag and catalog this data as it comes in.
Appreciate that. So Manish, you shared with me a concept that you guys like to talk about, which is machine data. Could you share with the crowd here what that concept is, what that looks like, that unstructured data that's being created that you call machine data, and then what you're doing with it, and how it's affecting the industry?
Sure, absolutely. So I think, as a Splunk, as a company, we've made our genesis is around being able to handle what we call machine data or unstructured data. And if you think about it, if a customer comes on your website or they buy something, a lot of the applications, the infrastructure, the networks that are supporting these applications are generating tons and tons of log files, or what we call machine data. And typically from a business perspective, people think of this as a digital exhaust. But the moment you start correlating data across all these different stacks, you can gain a very good perspective of that customer activity as to, where the person clicked, how they, what was the experience like, what was the delays in processing a transaction, so on and so forth. So what we are seeing more and more is that companies are using this data as more of contextual data. The other way to think about that is typically, let's say if you go to a store and you buy a shoe, it's a transaction that happened where we can say that Joe bought a shoe, and that's a transaction that gets recorded in a transactional database. But in today's day and age, a lot of the retailers have beacons, they have Wi-Fi devices, So using this data coming from all these machines, now you can contextualize that customer journey. So if Joe connected to the nearby beacon or the Wi-Fi device, now you can actually look at how much time did actually Joe spend in buying that shoe. Because the shoe happened is important, but if you want to get Joe back into the store, you have to make sure that the shoe buying journey did not take 5 minutes when it should be taking 2 minutes. Similarly, if you look at data from point of sale systems, you want to make sure that you are able to gain visibility into the transaction speed. Because if Joe is paying through a transaction like a Visa or Mastercard, and that transaction failed or the experience was poor, Joe is not going to come back. So this is again a point of sale system that is generating machine data that you can leverage to look at the payment process to figure out how efficient it was. So what we are seeing is the data that is the transaction data becomes a record. That's a reference record, but more and more companies are using machine data to provide contextualization, and then also combining that data with, for example, geolocation data to give more enrichment as well. So they can figure out, okay, Joe bought the shoe, it took that much time, it was in this zip code, and the weather was sunny that day. So getting that contextual information, enrichment information is very important. Is becoming actually more important than just the transaction data, and that's what machine data brings to life. And what we are seeing also is that machine data can be leveraged for not just a specific use case, but can be used for IT operations to make sure systems up and running. It can be used for making sure that the applications that are in production are performing to the specified SLAs. It can be used for IoT use cases. It can be used for business analytics use cases as well. So a lot of customers take that data and then start by using it for IT ops use cases, flip it around, use it for security use cases, which is becoming a very big concern these days in organizations, and then the same data can be leveraged for IoT and business analytics use cases as well.
One of the areas where we've had a challenge in the entire time I've been at Water Resources is trying to do end-to-end troubleshooting in a large distributed application. And so the promise of tools like Splunk is to be able to correlate logs from all these different places where this application is spread across, and pinpointing where latencies we're finding or specific problems. So it's been good.
One thing I'd add as well, so when you look at the telemetry data, as I mentioned previously, that each one of our arrays send home, we came up with this methodology that said, what if we could predict potential issues before they occurred? And it was based upon the fact of understanding the pathology associated to an event. And so somebody, let's say, had an outage. I could look at the digital exhaust or the logs from I love that term, by the way, or the logs from the devices, and I could find out everything that occurred before that outage occurred. We would then document each one of those. We call them fingerprints or digital fingerprints of an issue that occurred. And so when somebody calls in for an issue, we could identify very quickly if they're on the path to potentially getting to that end result, which would cause some sort of outage or disruption for them, and identify that early. And in fact, then we started to kind of implement it on an hourly basis. We'd run a health check across the entire population. We'd look then at how many people are on a series of paths in order to run into some sort of outage and automatically open up a ticket. A lot of people told us at the very beginning is, your support is going to suck just as bad as the big guys as soon as you get big too. It actually scared us quite a bit because we wanted to enable a much different customer experience, and just as you guys want to with your data sets. And by doing that, we couldn't just keep a linear cost model hiring the same amount of full-time employees to boxes that we sold, because we were growing way too fast and the cost model didn't make sense. And this is exactly why people suck long-term. But what we did instead is we started to predict issues and automatically open up tickets for them. And so 60 some odd % of our overall tickets are opened up automatically based upon machine learning and AI that we built into our systems to protect our users from issues that have yet to occur. Things that we'll be announcing next week are starting to predict issues that have yet to ever occur in the population, but start creating pathologies and fingerprints we think that may occur longer term, and then identify them well ahead of them actually occurring. This now is, think of it as kind of a self-driving infrastructure. It's now watching out for you and managing it better than even your people can, so that you can actually focus on things that are much more higher value to the business.